Hi students, in this video we are going to see some more problems related to integration by substitution. Now we will see this problem: evaluate integration of 4x square plus 2 into root over of x square plus x plus 1 dx. You know that this is the composition function and this is the normal function, because here x square plus x plus 1 is the first function. The output of this function is given to this square root function. Hence that is the composition function. Normally we take the first function in composition function as t. So if we take this x square plus x plus 1 as t, when we do the derivative on both sides, we get 2x plus 1 equal to dt by dx. 2x plus 1 we will get. So by doing differentiation we will check whether we can get other function. Here we get 2x plus 1, but here we have 4x plus 2. If we take 2 as common from these two terms, we will get 2x plus 1. Hence, before proceeding further, we are rewriting this question as this. We are taking 2 as common, so we get this expression. So this 2 is taken outside. So the same question has been rewritten in this form. Now we are proceeding to the solution. We know that this expression will be kept as t square because it lies inside the square root. Hence we keep it as t square. When we do derivative on both sides with respect to x, we get 2x plus 1 is equal to t square derivative is 2t into dt by dx. We need only dx. So 2x plus 1 will be kept that side and dx will go that side. So we get 2t into dt. So in place of 2x plus 1 into square root of dx, in 2x plus 1 into dx, we can substitute 2t dt, and then in the square root of x square plus 1 means we can substitute square root of t square. So square root of t square in place of 2x plus 1 dx, we are substituting this. 2 has been already, there is one 2, this 2 will go that side, so it will become 4t square. Actually, after simplifying this, we will get t here, another t is there. When we multiply it, we get t square dt. Integration of t square dt is, you know that it is t cube divided by 3. In place of t, we can substitute square root of x square plus x plus 1, then whole cube. I hope you understand this problem. Now we will move on to the next question. The next question is, evaluate integration of 4x plus 3 divided by square root of 2x square plus 3x plus 1. You know that this function is the composition function, in which 2x square plus 3x plus 1 is the first function. We will check when we do the derivative, we are getting this. 2x square derivative is 4x, derivative of 3x is 3, derivative of constant is 0. Hence, this 2x square plus 3x plus 1 can be considered as t square, because here we have square root. So we can consider this as t square. When we do a derivative on both sides with respect to x, we get 4x plus 3 2t into dt by dx. This dx can be transfer opposite side. So 4x plus 3 dx is equal to 2t dt. So in this place we can substitute 2t dt, and then square root of, in this place we can substitute t square. So the question can be rewritten as this. So we can take t outside, square root of t square is t, t will get cancelled, so we get integration of dt. Integration of dt is t, and this 2 as it is, and then in place of t we will substitute the expression, corresponding expression of x. So we get this answer. I hope you understand this problem. Now we will move on to the next question. Evaluate integration of 2x plus 5 divided by x square plus 5x plus 9 dx. Here 1 divided by x square plus 5x plus 9 is the composition function, and in which this is the first function. Let us check whether when we do the derivative of this expression, we are getting 2x plus 5. Derivative of x square is 2x, this plus sign as it is. Derivative of 5x is 5. Derivative of constant 9 is 0. Hence, when we do the derivative of this function, we are getting it. Hence, we can take x square plus 5x plus 9 is equal to t. Here we do not have square root. That's why we assume it as just t. Then when we are taking differentiation on both sides, we get 2x plus 5 is equal to dt by dx. So we can rewrite this as 2x plus 5 dx is equal to dt. So in place of 2x plus 5 dx, we can substitute dt, and in place of x square plus 5x plus 9 we can substitute t, which is in the integration value is log mod t. In place of t we can substitute this expression. Here we are seeing an important concept, integration of f dash of x divided by f of x dx. When we do the derivative of the denominator, if we get the numerator, we can directly write the answer as log mod denominator, log mod f of x dx. I hope you understand this. This is an important shortcut technique. I hope you understand this problem. Now we will move on to the next question. The next question is, evaluate integration of 6x minus 7 divided by 3x square minus 7x plus 5 whole square dx. If we consider this function, you know that 1 divided by 3x square minus 7x plus 5 whole square is the composition function, in which this quadratic expression is the first function. So we will check whether when we do the derivative we are getting the numerator or not. Derivative of these 3x square is 6x, derivative of minus 7x is minus 7, derivative of constant 5 is 0. Hence we can assume 3x square minus 7x plus 5 as t. When we do the derivative we are getting this expression. When we rewrite it, we get 6x minus 7 dx is equal to dt. So in this place we can substitute dt, here we can substitute t square. So we can rewrite this question as t power minus 2 dt. When we do the integration of this, we get t power minus 1 divided by minus 1, which is equal to minus 1 divided by t. In place of t we can substitute this 3x square minus 7x plus 5. I hope you understand this problem as well. Now we are moving on to the next question. Evaluate integration of cos x minus sin x divided by cos x plus sin x dx. This 1 divided by cos x plus sin x is the composition function, in which cos x plus sin x is the first function. So we will check whether derivative of this expression gives us the final answer. Derivative of cos x is minus sin x, derivative of sin x is cos x. Hence it is in the form of integration of f dash of x divided by f of x dx. So we can directly write the final answer as log mod denominator, here log mod cos x plus sin x. We will check the answer here. You just check it. Log mod cos x plus sin x plus c. You know how to write the step. You can directly write the step also, but you can copy these steps as well. It depends on in which question it is asked. Whether it is asked in 1 mark question or 2 mark questions, you can decide whether you can directly write the final answer or you need to write all these steps. Now we will move on to the next question. Evaluate integration of secant x divided by log mod secant x plus tan x. So normally we know that 1 divided by log x secant x plus tan x as composition function, and this log mod secant x plus tan x can be considered as t, and we will check whether we get other function. So we assume log mod secant x plus tan x is equal to t, log of secant x plus tan x is equal to t. When we do the derivative, log f is equal to 1 divided by f, hence we get 1 divided by secant x plus tan x. Then when we do the derivative of the secant x plus tan x, we get derivative of secant x is secant x tan x plus sin as it is. Derivative of tan x is secant square x, which is equal to dt by dx. When we take secant x as common in the numerator, we get tan x plus secant x divided by secant x plus tan x. We can eliminate them, we get secant x dx. That is the numerator, secant x dx. Hence the question can be written as dt divided by t, and the integration of this expression is log mod t. In place of t we are substituting this log secant x plus tan x. I hope you understand these problems also. With this I am completing this video. In the next video we will see some more problems related to it. Thank you students. Thanks for your cooperation.